Meow meow. It's raining right now. So, not very hard though. Meow meow meow. Let me see if I can put the live chat on now. Yes, I can. Meow 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 meow. Then the bitrate. There we go. Meow 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 meow. I wonder what to do. I'm gonna try to do this again. You know, yesterday I was failing. I failed this one. Maybe I'll do the easier part. And then it's no. Hold on.
Here, let me show you.
I think I really need overload here.
I won't hold you back.
Anyway, I'm pretty soon with the unusable soldering iron. I really wanna buy that one. I mean, as soon as I can, you know.
Let's get it on. Let's spark this. You're dead meat. Look alive. Come a little closer. You've been a naughty boy. Surrender. Let's light it up. Let's get it on. Let's spark things up a little. Gloves off. Let's light it up! I'm going in! Try not to. Let's light it up.
Meow, 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 meow.
Look alive. Teamwork is strength.
Oh man. I think this is the first time that I used the heal. I didn't need it earlier.
Let's spark. You asked for it.
I think we're gonna do it. Yep. There you go. Nice. What else can we do?
Off we go. Add.
Maybe I should have just crafted, no? But yeah, I think I'm gonna use all of my resin on this one. Yeah, I was watching videos about the soldering iron.
This is a perfect soldering joint. This one has too much solder. This one looks like it's a cold joint, and this one looks like it's starving. We've all made at least one of these mistakes, and if you're here, that's probably because you're trying to level up your soldering game. I've been doing this for 15 years, or probably more at this point, and I've learned quite a few tips and tricks that could turn anyone into a pro. So, let me show you, and trust me, it's actually pretty simple. And before we get started, make sure you are in a well-ventilated space. Open up a window or run a fume extractor. This one is not the best one, but it's better than nothing. Before we jump into soldering, I need to tell you a little bit about solder. I'm going to keep this extremely general. You could make an entire video just talking about solder, so I really want to keep it very brief. There are basically two types of solder. leaded solder and lead-free solder. Lead-free solder is a tiny bit more difficult to work with as it melts at higher temperatures. Then there's the leaded solder, which is a lot more forgiving and a lot easier to work with. So if you are a beginner, it is definitely easier to start with leaded solder. The next thing you need to know is that there are different widths of solder. They're meant for different purposes. If you're soldering large wires, you need to have a very thick core, or rather thick diameter of solder. If you're soldering tiny little components, you have to go for a very thin solder. So let's jump into the first step of actual soldering. Alright, before soldering, we've got some cleaning to do. For this purpose, I utilize 91% isopropyl alcohol. Anything above 70% will do. 99 would be preferable. I get my hands on 91 pretty easily, so this is what I utilize. This is perfectly good enough. I have mine in a dispensal bottle where it is super easy to actually dose just the tiniest bit, and I utilize it so much that this becomes extremely handy. Isopropyl alcohol is great for cleaning electronics and PCBs. One, it evaporates really quick. So if you soak your electronics in isopropyl alcohol, it will evaporate very quickly. That said, do turn off your electronics before using anything at all on them. Just a caution. Take the board that you're going to be soldering, the spot that you're going to be soldering, and make sure the metal is clean. There's no buildup, there's no gunk. This is the point of this step. Isopropyl alcohol will basically break down any dirt that's on top of the metal. Now don't worry about scrubbing it crazy, just make sure there's no big buildup on top of the joint that you're going to be soldering. Now the next step arguably is probably one of the most important. And to be honest, here's a story. I wish somebody told me to use flux a long time ago, because I was misled and led to believe that flux is not necessary. It is probably the most important step in the whole entire procedure. Now you might be saying to yourself, there is already flux within the core of the solder, and you would be absolutely correct. For majority of soldering, this is enough. That said, if you want to make a really pretty joint, flux cleans and preps your pad as you're soldering. And it is kind of like a magical assistant that just simply guides the solder to exactly where it needs to be. Flux activates under temperature, so it basically does nothing until you are applying heat to it. And it is super simple to use. Just put a tiniest bit of flux on the pad or on the through-hole component that you're going to be soldering. It's kind of like a guarantee. Basically, you might not need flux because there is flux in the core of the solder, but it is definitely a nice to have. And it will make your job so much easier. If you do anything, this is probably the most important step, I would argue, to get a very beautiful, I would call it even a perfect soldering joint. Now, if there is something even more important, it's probably setting the right temperature on your soldering iron. Too cold and the solder just simply blobs up and it doesn't actually spread and doesn't adhere properly to the metals. Too hot and you will burn your components, you'll scorch them. So, how do you actually know what temperature to set? Well, look at your solder. If it is lead-free, I would say start around 350 Celsius, go up to 370, more or less in that range. If your solder is leaded, go to about 320 up to 350. Now the temperatures will slightly vary depending on the solder type you have, so look at the data sheet, look at the manufacturer's spec, but that's probably a good range to start with. Now you also need to adjust for the type of job you're doing. If you're soldering tiny little components that are very small, you probably need less heat. If you're soldering a large, big wire that is connected to a ground, yeah, you're gonna have a lot more trouble heating that pad, right? So you have to set your temperature a tiny bit higher. Now do be careful, because again, you could go too high and you could scorch and burn your components basically, or you could go too low and the solder just was going to act like it's a solid basically. So adjust based on the job, and even if you're soldering a header and that last pin is ground, you probably have to actually go up in temperature for that specific pin. At least that's what I do, in order to have all of them soldered quite perfectly. But there's also a gotcha. How do you actually transfer the heat from the iron to the pad and to the joint? That matters a lot, and that's probably the thing that most people mess up. And by the way, if you want to learn soldering, you'll probably love my micro eraser project. It's a little DIY kit that you build yourself. There's a tiny bit of soldering involved, so hey, you'll get to solder. Everything you need to make one of these comes inside of a kit. And the best part, at the end, you'll have a really fun project that you could play with, that you can have fun with and experiment. And it's fully open sourced. So hey, and fully hackable too. You can actually change the firmware, write your own code and your own logic. And the gameplay is actually pretty fun too. The micro erasers spin out when they hit a banana, speed up when they hit a red mushroom, and slow down on that muddy puddle. Plus, I'm building out a private community. Lifetime access is $149, but yours comes free with a purchase of the micro eraser. Use the link below and make sure to check it out. You could grab one at stockuprototype.com. The first time you build this and then get to drive around your desk, you'll be hooked. Trust me. Now, speaking of soldering on the micro eraser, probably the biggest thing that a lot of people mess up is how they transfer heat from a soldering iron to the actual part that they are soldering. This is super critical. Once your soldering iron is hot enough, you have to make sure to properly clean it and then tin the actual tip itself. Without tinning the tip, if you're putting it down on a pad, there's not much heat transfer. So the point of the tinned tip is not to put solder onto the pad, but instead use the solder as a transfer, as a heat transfer. Basically a liquid that's transferring the heat from the soldering tip to the actual pad and the joint that you're going to be soldering. Now, again, and I want to stress this, it is not for actually soldering, it is to simply transfer the heat. And in order to properly clean your tip, I highly recommend a brass wool cleaner just like this one here. Add a little bit of solder to your iron, clean the tip again and again, make it nice and shiny. Then prime your tip with just the tiniest bit of solder. That solder is what's going to help you transfer the heat to the actual joint. So once you've tinned your iron, get that pad and the joint really nice and warm. And then let the actual pad and the joint melt the new solder. So then you're going to take the solder and actually start feeding the pad and the joint. You're not feeding the iron anymore. You're not trying to melt the solder with the iron. That's not the point here. Point is to warm up the pad and the joint and the lead, and then feed that solder directly to the pad and the joint itself.
Become a Shopee VIP member with your first month free. Get daily free shipping, daily 20% off vouchers, 0% interest with Activator every day. Plus, enjoy exclusive perks every Monday. Become a Shopee VIP member today. Shopee!
You're melting the solder with the joint, not with the iron. Now, if this step is taking longer than 3 seconds, that means your soldering iron is not hot enough. But if it is charring and burning, that means your iron is way too hot. So that's how you know if you have to go up or down in temperature on the iron itself. So once you've actually fed the solder into the joint, you're looking for this beautiful bell-like shaped, reverse bell I guess, maybe you could call it, and you're looking for a shiny, nice surface. If it is bulging and it is basically bulging to the outside, that means you fed too much solder. If it is looking empty or has a hole it's basically a starving joint, right? There's not enough solder. Add a tiny bit more. And if it is misshaped and just weird, odd looking, not a beautiful shape like this, that means it is probably a cold joint. Good news, it is easy to fix it. Let me just walk you quickly through all the scenarios one by one. If you've used too much solder, there is a very quick and easy way to fix that. One, take your soldering wick, and this is basically just a copper wire really with a little bit of flux. So you can utilize simply a copper wire if you don't have any wick. Take the wick, apply it to the joint that has too much solder. Take your iron and warm up the wick from the outside. Again, pre-tin your iron, make sure there's a good heat transfer. Touch it and let the wick absorb the solder, and that ends up with less solder on your joint. If you see a cold joint and your solder is uneven in spaces or has holes or whatever, then add a tiny bit more flux, heat up the whole entire thing again, and let it remelt. So to quickly recap, the perfect soldering joint starts with the clean, prepped surface.
My flux is not so nice, soldering paste.
Flux, a properly tinned iron. Remember, heat the pad and the joint. Don't melt the solder with the actual iron unless you're, of course, tinning it. That's the only purpose for melting directly with the iron. Feed the solder directly to the joint. Let it cool down slowly and nicely and smoothly, and you'll have a perfect soldering joint. I hope you learned something. Subscribe if you have. Check out stockupprototype.com if you want to support the channel, and I will see you in the next one. Thanks so much.
Seconds remaining. 5 seconds remaining.
Bruh, you cannot do something.
Mug Milo every day with triple advantage so you can grow up with champion energy.
Get ready to impress with Nivea Men Cool Kick. Enjoy up to 72-hour protection. Nivea Men is for skin.
So we're here today to figure out why your solder doesn't stick. I'm going to give you as many tips as I can, and we'll start with the soldering iron and go from there. Try and cover most of the problems that people have when trying to fix a solder joint, and they end up having contamination and problems, so we'll go through all those things. So let's talk about soldering irons. If you're going to buy a soldering iron, you should probably get one with a temperature control. So this is a fairly cheap soldering iron, but it does have a temperature control on it. And the temperature control is important because if you don't have the temperature control, you can see where this got really hot, the temperature control was too high. So a nice temperature controlled soldering iron, you want your tip to look like this. It's nice and silvery towards the end. So that's one of your goals. And the longer you can keep that tip like that, the better your solder joints are going to be. So let's start with a brand new soldering iron. We're going to take this soldering iron here and change the tip. And to change the tip, it's cold right now, so we pull this off, pull the tip off, and we're going to pick a new tip. Now, these tips are for different style, different tools for different jobs. If you need a lot of heat in a big joint, you're going to pick something like that. But you're not going to want to do fine electronics with something like that.
30 seconds to
You're going to want to do fine electronics with a tip such as this. So we're going to do this tip. We're going to put this tip on there, and we're going to heat the soldering iron up. We're going to make sure this is nice and tight, and we want our temperature to be somewhere around, let me flip it this way, somewhere around 350 degrees, 700 degrees Fahrenheit, 325 to 350 Celsius. So while that's heating up, you're going to want some good rosin soldering flux, not plumbing stuff. You want to get the actual electronic stuff. Now, granted, Radio Shack is gone. I don't know if you can still get this on the web, but you can get electrical soldering flux from eBay. So we're going to start by getting some flux on the tip, and while we're here, you can see you make a lot of fumes, so we're going to turn on our air filter, and that's probably a good idea to buy one of these if you're going to be doing a lot of soldering. So you can see the tip is pretty black. So what we're going to do at this point is run it through, and I can tell you these brass sponges are the best. And we can see that's a little too hot, so we're going to turn it down. And we're going to try and tin it. And when we tin it, we're going to cover the whole tip where we're going to be soldering with solder. And you can see now that that tip is nice and silvery, and that's what you want to keep. You want your soldering iron to keep that. Now, when you get a soldering stand, some of them come with sponges like this. If it comes with a sponge, take this and throw that shit out, because what a sponge does, if you wet this sponge down and put it in there, it's going to cause thermal shock every time you put the soldering iron in that sponge. So yeah, it was a great idea way back when, but when they came out with these copper or brass, this one has brass. If you can get a hold of one of these with brass in it, it's really nice, because you can just stick your soldering iron in there and clean that right up. Now we can see she's still just a little bit too hot. We're going to go down to 250, but that's probably not going to be enough. Now it seems to be working. 250 seems to be okay. So we're going to go with that. So 250 is where you want it. You got that tip nice, and it's nice to have this sponge because after every solder joint, if you clean up your tip, you'll have a much better chance of getting a good solder joint. Now let's talk about solder. This is what they call lead-free solder. This stuff is very difficult to work with. Your joints have to be exceptionally clean to get this to stick. We're going to play with this But I will tell you that it's much harder to get a good solder joint with this lead-free solder than it is to get a good joint with the old stuff that's been around. This stuff is excellent, easy to work with, but supposedly you can't get it anymore. You could probably get it at a ham festival or something like that, but this has lead in it, and that's why you can't get it. And you want to wash your hands real well. If you're holding it like I am, I'm going to have to wash my hands and not put my hands close to my mouth. But we're going to do this stuff. So it's a good idea to tin your tip with the stuff that you're working with. And you can see we got a nice, let me put it in focus here, pretty nice silver colored tip there. So we know that our temperature's good, and we know that our tip is tinned real nice because solder will just, in that area, flow on very nicely. A good way to learn how to do electronics is to buy one of these learn to solder kits, because they have a lot of nice stuff. They got a resistor color code thing here. They got a transistor identifier here, LED identifier, and they give you some pretty good instructions. So we have this circuit board that we just got, and you can see it looks shiny, but it's got some oxidation on it. So what you want to do before you start a kit is take a little bit of Scotch-Brite.
You know, you can also like etch it, chemically.
And just lightly go over the runs and clean that oxide coating off of there. It'll make your job a lot easier. So there we have the copper nice and clean. The nice thing about these solder suckers or fans or whatever you want to call it, they have holders that come with it. Alright, so we're going to install a resistor. So here's a trick for you. If you take a micrometer and you go to the inside, we want to set it just so we have the inside of the holes. We take our resistor that we want to put in and we put it across, center it up,
Meow
put it
meow,
across,
hello.
and then we can just bend our leads up.
How are you doing? Hello.
And then we take our resistor that we want to put in the slot. So we have the resistor, it's fairly equal on both sides, and that's where we need it to be. So on the back side, we're going to spread the leads out so the resistor holds in place with our finger holding it tight. Spread it out. Then we're going to take our solder, put it like this, re-tin it again, and when we go to solder, we're going to hit the pad and the resistor lead at the same time and slowly fill in that joint. Same thing, hit the pad and the resistor at the same time. Now, you can see with the lead-free solder that the joint is kind of dull. So we're going to clip those leads. We're going to tin our tip, clean it off with the brass thing, and we're ready to go. Hit the pad and the resistor at the same time. Sometimes it's good to count to 5. 1, 2, 3, 4, 5. Pad, resistor at the same time. You don't want to be on here too long because if you're putting a transistor in, you could fry the transistor. So we're going to go ahead and pull that off there. And look at the difference. Okay, the old solder kind of works better. So I'm not telling you what you can or can't do, but the old solder with lead in it definitely has a better look. I believe it may make a better joint. I don't know. So when you're done soldering, it's good to put a little alcohol on there and scrub it off. So when you're done, it's often good to try and get this in focus, but it's often good to inspect your joints. Make sure there's not a bunch of crap in them, and make sure there's no holes or pits or anything like that. So let's talk about old crusty joints. This is some old crusty wire, and this is an old crusty joint, kind of what you will find in older electronics or older pinball machines. Say this wire, let's assume this wire broke and we got to put a new one on here. So the first thing we have to do is get that out. Go ahead and tin the tip.
That must be very hot, like to melt that the old solder.
Pull the wire out, and you'll notice the outside of that is pretty crusty. So what we're going to do is take a solder sucker, try and get as much of that out as we can. So once we have that clean, we can take a piece of Scotch-Brite, or you could take a file, small file. You could take some sandpaper, but you want to clean this up as best you can. There you see we have a nice silver cleanup, but you want to clean as much of this stuff off, and you can in fact hit it with the alcohol. Get as much of that off. Cleanliness is not next to godliness when it comes to soldering. Alright, so I don't have another piece of wire, but you can see I don't have another piece of wire, but the wire is kind of crusty, okay? So if you run into a situation where you have this crustiness on the wire and you need to redo the joint, you can take and clean that up with a wire brush, small piece of sandpaper, clean it up as best you can. So once you get that, you can twist it together. Put some rosin on it. So what we're going to do, with our tip nice and clean, we're going to go ahead and tin this. Let it cool down. And then we're going to bend it. Now imagine this is in an old pinball machine or an older piece of electronics. We bend that up. We put it through. And you can smash it down
He looked at hooked.
at that point. So we've got it smashed down at that.
I don't really know that anymore. I used to, but not anymore. I prefer solid, clean joints.
Point. We're going to make sure our tip is nice and clean. Hit it with the brass sponge. Hit the wire and the terminal at the same time, and you see what happens with old wire. It's not the greatest of joints. But in the end, you have a nice solid joint, and you can see the solder flowed into some of the wires there. It's ugly, but that is the case of old wire. That's what happens with this old stuff. It gets so corroded that it's hard to get clean, and the only way to get a good solder joint with this stuff is to take the solder or clean it up as best you can and then get a good solder joint. And that is the problem with old wire. In this case, I don't think I'd accept that joint. I would take it out of there, cut the wire back to where I could find some good stuff, and redo the solder joint. But that's what happens. You get this kind of stuff where you have corrosion and stuff that gets into your solder joint. That's not a great connection. So I'd get rid of that, put some new solder, or redo the solder joint. So in this case, this is what we want. I replaced it with a new piece of wire because the old piece of wire was so bad. And that could be part of your problem. If the wire in the equipment is that bad, you may have to replace it or splice in a new piece to get a good connection. But a bad connection will cause you problems down the road. So you want, if you have the wire outline, you can see the tab, everything is nice and shiny. It's on there good, it's not going to come off. That's what you want. So if your solder isn't sticking and your problem's old wire, you might want to look into that. This is a place where it's tough to get solder to stick. Say you had to make a ground to the chassis and you wanted to solder a wire, and let's pretend this piece of tin is chassis ground. What you have to do, clean up an area really good. So then when you have this area nice and clean, this is where you would go for the big tip. So here we're at 250. You might have to use more heat, but we'll give this a shot. So you heat up the metal and you heat up the solder. And what's going on is we got flux going in from the solder. That's the yellow stuff that you see. So we get that puddle real nice and stuck to the metal. So then we're going to take our wire, strip it, then we're going to tin our wire. We got our wire nice and tin. And then we're going to go back and heat up the puddle and heat up the wire at the same time. We're going to let that cool, and then you can see,
Oh, that's nice.
we can't pull that off there. So that's a good joint. So a lot of times on guitars and guitar amps,
Yeah, the potentiometer and the backplate. Especially the tremolo plate tremolo bridges, tremolo bridged guitars with Fender Stratocasters.
They ground the pot, and you would do basically the same thing. You would clean off an area where you wanted to hook the ground. The problem with pots is you don't want to stay on the area too long. And I'm going to go up here on the end because this is the strongest part of the pot and it's not going to transfer as much heat into the pot. So we're going to tin our tip, hit it with the brass sponge, I call it, and then just get that so that it sticks. Then you can take your wire and lay it in there. Transfer as much heat in. The problem with pots is you don't want to stay on the area too long. And I'm going to go up here on the end because this is the strongest part of the pot and it's not going to transfer as much heat into the pot. So we're going to tin our tip, hit it with the brass sponge, I call it, and then just get that so that it sticks. Then you can take your wire and lay it in there. So you can see the wires laid in there pretty good and it's not coming off. So that's how you would do that. You need more heat, you need a bigger tip, and then you can solder basically on the tin chassis or the tin of the back of the pot. And like I say, on the back of a pot, you don't want to leave that on there too long because you can affect the resistance of that pot by overheating it. And just for demonstration purposes, this is what they call a resistance soldering iron. It's used for doing connectors with big copper, like end connectors, any type of connector where you need a quick solder joint because it heats up fast. These are carbon tips and they're made just like the lead in a pencil. So basically you have a transformer with a high and low output, 6 volts or 3 volts I believe it is, and then that feeds these two carbon elements and they heat up really fast and you can solder stuff. So just as a demonstration, I'm going to grab these two pieces of brass and solder them together. And you can tell it's still kind of hot. It's a really nice joint. So these resistance soldering irons are good for making cables, and they're also good for making brass models because they heat up real quick and then solder really well. You can see I'm trying to pull that apart and I can't.
I have lagnat, I have
body pain? Pag flu, pwedeng flu. Mag-Bio Flu. Dahil pag may 2 symptoms, pwedeng flu yan. Kaya anumang sintomas ng flu.
Ang dami ko nakikitang iba't ibang chopping boards. May kahoy at may plastic. May difference ba talaga kung ano ang gamit ko? Hi, I'm Chef Eric, Maggie's Culinary Development Chef for 16 years. This is Paano Ba To? Everything you need to know to start cooking. So ngayon magpo-focus muna tayo sa plastic chopping board and wooden chopping board. As a beginner cook, pwede mo namang gamitin pareho. Katulad itong plastic, as long as malapad, makapal at sturdy, hindi nagwa-warp, pwede mo itong gamitin for your food preparation. Ako mas preferred ko yung plastic kasi mas madaling linisin. Pag napatuyo mo, very sanitary. Unlike the wood na may tendency na mag-absorb ng water. Actually, may iba't ibang kulay pa nga ng chopping board. Yellow is for poultry, red is for meat, blue is for fish and seafood, green is for fruit and vegetables, brown is for any cooked meat, and yung white ay para sa breads and dairy. Ang kailangan mo i-consider sa pagpili ng good quality chopping board, kailangan malapad para marami kang ma-prepare. Kailangan medyo makapal para sturdy, and of course, hindi nagwa-warp para hindi nag-chip off yung plastic when you cut using your knife. Mag-invest sa mga gamit to help you become a confident cook. Stay magiskarte!
For more Magiskarte tips, visit nasaygoodness.com/ph.
Frick.
So we're here today.
Hello, my name is David Riddle. Welcome to our YouTube channel, How to Home Life. Today I'm going to demonstrate how to properly solder various electrical connections and metals together. It seems like I've been soldering all my life. I bought my first soldering iron when I was 8 years old because I was fascinated by electronics and needed that iron to build electrical and electronic projects. I've used the skill of soldering throughout my career as an inventor, designer, and manufacturer of professional tools in the fields of mechanics, electronics, and optics. My soldering skills allowed me to build and market thousands of technical products, such as custom variable power supplies, audio and video equipment, underwater cameras, 3-axis camera cranes for the film and television industry, loudspeakers and mixers for live sound reinforcement, and this list could go on for the entire video. I have also used soldering in repairing countless electronic and mechanical devices. For example, I have reconditioned and repaired thousands of laboratory DC and AC power supplies and resold them on eBay. This was not a hobby. I was able to make thousands of dollars with the money I generated from repairing these power supplies and other electrical and electronic equipment. If you want to be a maker, inventor, manufacturer, or you just need to repair technical devices, this is the video for you. This video is for the beginner who's never soldered before, and also for seasoned soldering veterans. Whatever your skills are, I guarantee you will learn something from this video. I will begin by showing you the basics of soldering tools and techniques. Then I will demonstrate real-world skills in soldering different items such as splicing wires, terminating electrical connectors, building and repairing printed circuit boards, and many more examples. Before we begin the basics of soldering, I would like to ask you to please like and subscribe to our channel. When you subscribe to our channel, it helps us support our videos and allows us to make even more videos. Also, please add any questions you have in the comment section, and I guarantee I will answer all of your questions. And last, if you would like us to make a video on a specific subject, please let us know. Because I'm demonstrating several examples of soldering tools and techniques, this video is longer than our usual tutorials. To navigate through the video, we have divided it into chapters. We did this as you may want to go directly to a certain chapter that interests you. Here are the following chapters. Chapter 1. What is tin and lead solder? Chapter 2. Tools required for soldering. Chapter 3. flux and oxidation plus soldering various metals. Chapter 4, splicing single wires together. Chapter 5, splicing standard lamp cord. Chapter 6, soldering wires to electrical connectors. Chapter 7, soldering and desoldering printed circuit boards. We have provided a color-coded graphic at the bottom of your screen that allows you to scroll through the video and easily find the chapter you are looking for. We have also listed the chapters in the description section. The first thing we're going to talk about in this video is the solder itself. Now, John, my producer, is going to jump in with some questions if I don't make it clear. But let's talk about the solder that I'm actually using right here. This is tin lead solder. I do not use non-lead solder, and the reason I don't is for a very good reason. Number one, RoHS, which is RoHS, is a European Union that mandated no lead in solder, but the military has a permanent exemption from lead in solder. Why? Because of the durability of and history of tin lead solder versus all the other formulations that don't have the lead in it.
Well, let me just real quick question. For people who might know nothing about solder, would they say, "Ooh, lead, that's scary. It might hurt me. What if there's fumes, or what if it gets in my eyes?" What do you say to that, Dave?
Well, listen, there is a propensity for young children to suffer from lead poisoning, especially from paint chips and other things like that. But they've allowed solder with employees for more than 100 years, okay? And the most recent health actions have not proven that the solder fumes are a problem. But let's talk about the actual solder itself. This particular solder that I'm showing you today and will be used in all of our demonstrations is a Kester product with mildly activated rosin core solder, meaning that the core holds the rosin and the lead and the tin go around it. The alloy of this particular solder is 63% tin, 37% lead.
And so where is this something you can buy at Home Depot?
It's not how I pronounce like resin. Is it actually rosin? Oh, it's freaking resin.
Resin.
Yeah, it's
Or is
Generally, no, you can't buy 6337 solder. Generally, you have to buy it online. You simply type in solder 63/37 and it will come up on the Google search.
Why is it not available at Home Depot? Is it some special
Because typically
solder?
the Home Depot is going to sell 60/40 solder. Now the difference between 60/40, 60% tin, 40% lead, is because this particular alloy at 6337 has the lowest temperature melting, coupled with the fact that it doesn't have a plastic state. Now what that means is that when solder goes from a liquid state to a solid state, it goes through a plastic state. This particular solder, being a eutectic alloy, has no plastic state. It immediately goes from liquid directly into solid, not allowing any bad connections, which is typical during the plastic state. And any vibration or anything else, it can cause a bad connection. That's why this solder is very commonly used in most military and other applications.
Okay, everything so far is clear for me, but for beginners, everything's clear except rosin. Okay, why is rosin on there? What is rosin? What does rosin
Well,
do?
there's different fluxes. First of all, the reason that the flux is there is to prevent oxidation. Everything, 21% of oxygen in the air will affect how the solder works. There's a multiplicity of reasons why rosin core solder is used in electronics. Number one, it's used to prevent oxidation of the joint. And the way it does it is when it melts the rosin, which melts at a much lower temperature than the tin and lead, it covers the entire joint with a layer that prevents the oxidation of the solder. And I'm going to be showing you how not to use solder and rosins that will go bad on the joint. I'm going to demonstrate
is
that.
flux and rosin the same thing?
Yes, flux and rosin core flux versus there's acid core flux. There's all kinds of different fluxes available. There's water-based flux, there's solvent-based flux, there's rosin-based flux. They all have different properties and different characteristics, but generally in electronics and electrical applications, you want to be using mildly activated rosin core solder.
Okay, so this is the only solder we're going to use in this video.
This is all of our demonstration is going to be using this particular alloy of solder, the diameter of the solder, which is 0.031 or 32nds of an inch. You will see how it applies to all of the activities that I do in this
Does
video.
this include when we're going to do sheet metal to sheet metal?
Absolutely. It's all going to be the same material.
So this is going to cover everything.
This solder will cover everything we're going to do. It's called soft soldering. There's hard soldering, which is brazing and silver soldering, but this is soft soldering. And soft soldering is the most common solder used in both electrical and electronics.
Okay, anything else on the solder before we move on?
Yeah, we're going to move on to the availability. Like I said before, just simply Google solder 63/37 and it will come up. Put a quotation mark before the search. Now we're going to talk about soldering irons and soldering guns. The soldering iron that I purchased when I was 8 years old was a traditional soldering iron. It's very much like this Radio Shack version in a Hakko holder, but this is just a heating element and a tip that is heated to melt the solder. Now realize, my father taught me this at 8 years old. He said, son, do not melt the solder. The soldering iron is to heat up the material you're soldering to the temperature that solder will melt on it. Not dripping it on it. It's designed to heat the object you're doing. That's the key. Now the problem with a simple soldering iron is it has a given temperature. This is a 40-watt iron. That means 40 watts of electrical energy going into it, and it produces about a 600-degree tip. The problem is that may be too hot for some objects. We don't know. I don't know. All I can tell you is that this soldering iron will do any job we're going to do today. It just doesn't have as much control over it. There was an attempt in this soldering iron to have a temperature control. Unfortunately, the temperature control has nothing to do with reality, meaning that it's just a dial and you don't really ever know what the temperature actually is of the tip. I measured this again at full power. It goes to approximately 600 degrees. At low power, it's no more than 200 degrees. So, but unless you have a precision calibrated thermocouple like this to measure the temperature, there's no way that you can figure out.
Describe a situation where you'd want to know an exact temperature.
Okay, this game is over. Solder is too strong.
Dial in it, the exact temperature.
Part of the reason is when you're working on delicate circuit boards, very many times you need a lower temperature so that you do not delaminate the copper foil on the circuit board. That's one of the reasons.
Is there something specified on the circuit board of this is the temperature that you're going to use to work on this circuit board?
Typically,
or you just know that?
If you look in active components, they have a maximum soldering time based on that specific temperature that you're going to apply to that component. But the main problem is doing not only assembly but also rework on circuit boards where the higher temperature can destroy the circuit board. And so you really want to have some control. Now,
what's an example of a temperature for a circuit board?
It varies depending on the type of copper clad that's on the board, what adhesives are used. There's all kinds of different things.
So for novices, you could destroy a circuit board if you don't know what you're doing.
Yes, absolutely. Now, one of the techniques that Weller came up with was a temperature-controlled soldering iron. When you change the tip, the back of the tip shows the temperature of what the tip. They come in 600, 700, and 800 degree tips.
So in other words, that specific tip will only go to that specific temperature.
Right. Well, it varies slightly because this is a bistable thermostat in here. The way that this works is from the Curie effect, excuse me. The Curie effect is a phenomenon that Pierre Curie discovered, and that is certain alloys of steel will either attract a magnet or at higher temperatures will not attract a magnet, and that's how this soldering iron works. It basically has a magnet that closes a contact, and when the tip heats up to a certain temperature, on the back of the tip right here is a little piece of steel, a special alloy steel that sets the temperature based on the particular alloy of that steel. But that's how this works.
Well, how often have you actually used that?
Well, I actually have used one of these Weller temperature-controlled irons for many, many years, more than...
You know, I'm gonna end the stream after this. It's just a quick stream, and you know, it's actually Sunday. So we'll see what happens. It's Sunday in the Philippines already. Alright, so yeah, this was just a short stream. See ya. You guys have a good day or good night wherever you are, okay? Bye bye. Thank you for visiting.